Hey guys, this is 12.1 Probability Distribution, and we are going to look at the first 4 examples in this video. This is the easier of the 2 days. Not that the second day is really that hard, but this might be more familiar to some of you. Alright, looking at example 1, this is making a frequency table. Super duper easy. Basically, you're going to have 2 ways of keeping track of that data. You can use a tally table, tally chart, whatever, and then the actual official table presentation. So your tally sheet, if you will, it just has the marks and it keeps track of it, and it helps you go organize your data as you're going along. Whereas the table actually says the official name and how many and the total number. So one example that we can use is different colored eyes in a classroom. So if we take a look at this group here, we can go through and count the number of blue, brown, and green eyes that we have. Now you can do any number of things, but I'm going to go through and say, okay, got 1 blue, 2, 3, and then 4. So 1, 2, 3, 4. Brown, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So we have 15 brown eyes. Ooh, it's hard to keep that straight. Sorry about that. And then we have 1, 2, 3, 4, 5, 6 green. Alright, so there's 15, 20, total of 25. Alright, so then you actually come over here to your table, and this is what you're going to present. So you would write that as 15. Green would be 6. Blue would be 4, and your total is 25. Super duper easy. Alright, now let's go and take a look at your second example. This one is finding the probability of an event, of a single event. Okay, so, and I should be more specific, the experimental probability. Alright, so using the frequency table that they have given us here, it says find the probability that a student is involved in at least one extracurricular activity. So that at least is the key here. That means we need to look at one or more. So that's going to be these 2 here. So we're going to add these 2 together. So we have 360 plus 144 gives us 504. Right. So the probability of greater than or equal to 1 activity is going to be 504 over the total possible, which in this case is 720. Now when we actually put that into the calculator, that's going to give us 0.7. But we cannot express probability as a decimal. We either need to do it as a fraction or as a percent. So we're going to convert that 0.7 to 70%. Alright. So hopefully so far so good. Now looking at example 3, we have a probability distribution. This is probably the first time that you've seen this, and at least displayed in this way. We are given 2 number cubes in this one, and we need to find the sum of the cubes. The smallest we have is 2, the largest we have is 12, and we have everything in between. Then you need to find out how many times 3 would pop up. How many possible times could 4 pop up? How many possible, so on and so forth. And then we also make a graph to correspond with that. Now taking a look at the one for your notes, we have suppose you spin 2 spinners. Each spinner has 4 possible outcomes. 1, 2, 3, or 4. So we've got a spinner here, and let's see if I can do this. We have 1, 2, 3, 4. Yeah, I don't know why I did that again. All right, and then we have a second spinner, and have 1, 2, 3, 4. How about that one? I got it right that time. Okay, so now we want to look and see what are the possible outcomes if we add those numbers together. Well, the smallest possible we have is 1 plus 1, which would give us 2. And then we have 3, and then we have 4, 5, 6, 7, and then 8. And that makes sense because the largest numbers we have are 4, so 4 plus 4 is 8. Now looking at the frequency, if I spin 1 on this one, I have 1. All right, I could either have 1, 2, 3, or 4. And then with the 2, I would either have 1, 2, 3, or 4. And then with the 3, so this is one way that you could do all of your total possible, and that might help get everything squared away. And also that also takes care of no duplicates. Okay, so looking at this, when we have 1, 2, 3, 4 times 4, so we have a total of 16 possible outcomes. All right. All right, so I have 2, that is the only one that adds up to 2. This one is 3, this one is 4, this is 5, that's 3, 4, 5, 2 plus 4 is 6, 3 plus 1 is 4, 5, 6, 7, 5, 6, 7, and 8. Okay, so I have 2 that equal 3. I have 1, 2, 3 that equal 4, and I said 2, but then I wrote 3. All right. Now 5, we have 1, 2, 3, and then 4. For 6, we have 1, 2, 3. For 7, we have 2. And for 8, we have 1. And so now we're going to find the probability, and that is the total of the outcome over the total possible. So we have 1 over 16, because that's how many possible outcomes we have. 2 over 16, 3 over 16, 4 over 16, 3 over 16, 2 over 16, and then 1 over 16. Again, corresponding the outcome of that particular trial over the total possible outcomes. Okay. Then we are instructed to make a graph. Now you can make it a histogram, which is where your bar graphs, your bars touch each other and there is no gaps, or you can do a simple bar graph. I am more of a fan of the bar graph because then I don't have to worry about everything being the same. All right. So if I have this, the highest number I have is 3/16, so I'm just going to go ahead and put it to 3/16. This is the probability of the outcome. And then down here, this is the sum of the spinners. And we have 2, 3, 4, 5, 6, 7, and 8. So for 2, we have 1/16. For 3, we have 2/16. 4 is 3/16. And I think you guys caught on right there. I realized I forgot the 4/16. Mondays, right? Oh, okay. That's not a very good bar graph. All right, that's 4/16. 6 is 3/16. 7 is 2/16. And 8 is, too high, 1/16. Okay, so there would be a bar graph. Ignore the fact that they are wobbly. It's rather hard to draw a straight line on this tablet thing. Okay, so that would be it. And then finally, the last question we had was an example of a Punnett square, where we are trying to find the probability of two events, basically two combined events. All right, so with the one for your notes, we had the information given to us of inherited genes. We have an inherited gene from one recessive and one hybrid. So we're looking at these, and this is lowercase r, capital R, lowercase r. So these are my possible outcomes. We have a total of 4 possible outcomes. There are 2 capital R, lowercase r, and there are 2 lowercase r, lowercase r. All right, we are asked to create a probability distribution, a graph, the probability distribution of each sample space. So for A, we are looking at the genotype distribution, just the RR, capital RR and lowercase rr, and that is a nice little hint to us that that's what we are graphing. So we have little r, capital R, little r, little r, little r. We have 1, 2, 3, 4. I'm going to go ahead and separate this into 1/4. Okay, so for capital R, lowercase r, we have 2 out of 4, which then makes that 1/2. And then for the little r's, we have little rr, little r, little r. So that's 2 out of 4, which is again 1/2. Okay. Now for the second one, we have plant color distribution. Well, it tells us we have 3 possible colors. We could either have red, pink, or white. The red is 2 capital R's, pink is a combination of capital R and lowercase r, and the white is both lowercase r. So we're going to have 3 possible outcomes. We have red, we have pink, and we have white. And I'm going to go ahead and mark these off. Okay. And so this is the probability of the outcome, and this is the plant color. All right, so for red, we have no double R's, no double capital R's, so we're not even going to put a bar there. For the pink, we have 2 capital R, lowercase r's, so that's 1/2. 2 out of 4 is 1/2. And then for the white, we have 2 out of 4, which is again 1/2. Now, these graphs look very similar. However, this one is for the genotype distribution, and this one is for the plant color distribution. All right, guys, that about does it for the first day. Hope everything made sense. If you have any questions, please let me know.